Okay. So, good evening, everyone. Thanks for joining this fifth week session of NPTEL problem solving session on the course air pollution and control. So, last week I could not able to take because of the network issue, and I was also busy with the inventive program in IIT Madras, and now I came back to NIT Trichy. So, today we will start this fifth week session, and don't forget to attend the tomorrow session, that is the sixth week session, 6 to 8 p.m. As usual planned. So, as a small introductory note about me, this is Saravanan, PhD scholar and Prime Minister Research Fellow of Department of Civil Engineering in NIT Tiruchirappalli. And as a part of PMR of TA course, I'm taking this problem solving session on NPTEL. So I'm a PMR of scholar from 2021 onwards, and I have taken already two courses under Rajesh Kumar Dubey sir and Ajay Kalamrat sir, and solid waste management and plastic waste management. And this time I'm taking air pollution and control. Yeah. So today we are in the fifth week, and we have in the first 4 weeks we have discussed about what is air pollution, what are the different pollutants, and how to identify different pollutant, and what are the problems of the air pollution to the environment, to the human health, to the animals, to the materials, and all we have discussed, and various inventories we have discussed in the last week, and emission models we have discussed, like the plume emission models and the box models, that and all we have discussed in the last week. So this time we are going to for that emission models to be predicted, we need a data. So how to find the data and what are the sources of data, that and all we are going to discuss in this week. Okay, in this week we have 5 lectures. Of all the 5 lectures will be around the emission inventories on transportation, on agriculture, on industries, and from burning, and like residential and commercial burning, and finally we are going to see the application of remote sensing on this emission inventories. These are the five overview lecture we are going to see. So this 2 hour session will go like first 1 hour session. I'm going to take the same lecture material what sir has taught in the YouTube videos, and in the second 1 hour we are going to discuss the problems of old assignment problems. Okay, so you can ask, you can unmute and you can ask doubts anytime during the session. Also, you can put it in the chat box. I am periodically seeing the chat box. I will answer your question during the session also. Okay, so we will start the session. Yeah, we will move on. So, this first fifth week, we are going to see about the emission inventories. First is the transport emission inventories. What is emission inventory that we had seen in the last week's last lecture? Emission inventories are the data collection procedures. The inventories are the data collection procedures. Here, emission inventories are air pollution related data collection that will help you in giving the input values to the models. Okay, so that will vary based on different emission methods. One may be different sources of emissions are there, like from transport we can expect emissions, from urban burnings we can get emissions, from agricultural burning we can get emission, from industries will get emissions. So first, how to model, how to get the data of transport emissions, that and all we are going to see in this. Okay, got it. So the transportation sector is the major responsible for the CO2 emission. As we know, you can see in Delhi also nowadays you can see the repeated pollution due to air pollution. I mean transportation that may emit this NOx, SOx, and carbon monoxide. If the engine is not good, then incomplete combustion will happen and it will emit carbon monoxide. And globally, you can see 25% is due to carbon dioxide emission is due to fuel combustion. And in India, you can see third most CO2 contributor sector is our transportation sector, that is the road transport contributes. Out of that, 90% is CO2 emission. Okay, so you can see the projections of the statistics. Here you can see like the growth rate of vehicle ownership is increasing by 10.4% for two-wheelers, because after COVID, if you see, most of the people are moving to two-wheelers and four-wheelers instead of traveling in public transport. That is the one major you can see some of the rumors that we can't use the public transport because due to the spread of viruses. During that time onwards, people are moving to this type of personal vehicles, so that increases the growth rate of this vehicle ownership by 10%, and the cars you can see for 11%. That again increases the emission. That's why nowadays in metro cities they are promoting to use the public transport to reduce the level of this type of emissions. Okay, so the source of emission from the transport may be of two types. One is exhaust emission, another one is non-exhaust emission. Exhaust is the emission which is coming out of the tailpipe, whatever your what we say silencer in your bike, or whatever the tailpipe in your car, that and all will emit some, that is called exhaust emission. Other than that, what are the emission that is happening, that are all non-exhaust emission, you can see. So exhaust emission will contains the emission from the fuel combustion, by any petrol or diesel what you are keeping, that combustion produces some emission, that is carbon monoxide, carbon dioxide, hydrocarbon, because fuel is a hydrocarbon, so you will get expect the hydrocarbon in your emission, and NOx and particulate matter is there. So earlier lead petrol was there, nowadays it's banned in India. So if lead petrol was there, then your emission may contains lead also. Okay, so these are all exhaust emission. Other than that, what will happen? Refueling losses may also release some hydrocarbon and volatile organic carbon, because whatever the fuel we are using is volatile in nature. So that may directly convert into gas, and it will be emitted from to the atmosphere. Other than that, what will happen? The evaporating emission, that is from the fuel tank again, and the aberration of tires, brakes, and clutches. So whenever you are putting brake, that will abrade your tires. So from your tires, some microplastic may emit, some carbon may be emitted, and particulate matter may be emitted, and the road surface may also erode, and it will also emit some particulate matter. If it is a concrete road, or if it is a bitumen road, that will also erode, and it will emit the particulate matter into the atmosphere. That is another type of non-exhaust emission. You got it. So exhaust emission will be emitted from the tailpipe of your engine chamber. That may be due to the incomplete combustion of the fuel. And what are the pollutant we can expect from exhaust emissions, like carbon monoxide, hydrogen, hydrocarbons, and nitrogen, NOx, everything, and then carbon dioxide, CO2, CO, both will be there, and then particulate matter will also be emitted. You can see the tailpipe emissions here. Okay, then sources of vehicular emission. What are the sources, like other than this exhaust emission? What are the other sources? Evaporative emission and non-exhaust emission. Evaporative is from the gasolines, that may contain hydrocarbon and volatile organic compounds, and non-exhaust emission is generated from the aberration of tires, roads, and your brake wears. So all these three may wear and emit the particulate matter and heavy metal. This is main. Non-exhaust emissions contain particulate matter 10 and 10 2.5. Also, the heavy metal may also be emitted from the brake wears. You got it. Then vehicular emission inventory, how to get the data about this vehicle emissions and how to calculate that emissions. That's what we are going to see. So we need to know what are the factors that will affect this emissions. So for that we can see, like, what are the emission models are developed based on these factors. One is vehicle type. Our car may emit differently and our bike may emit different. So you can see, and also the age of the vehicles. So that and all will contribute to your emission, and emission standards, fuel category, various correction factors, and vehicle kilometers travel. That is the age again. That terms you can say. So emission, what are the input you have to give? What are the vehicle population? How many vehicles are traveling the road, and what are the type of the vehicle, age, and technology? Because nowadays you can see the engine models may vary and it will emit lesser pollutions. So our engines are also designed based on higher combustion efficiency, also to reduce the emissions. So these are the two factors need to be considered for the design of engine. So vehicle technology also will be contribute to your emission. Fuel type, maybe petrol or diesel, or if it is that's why now we are moving to e-vehicle. So e-vehicle will emit less, but the production of energy will emit a lot, but it is a controlled environment. So again, it will reduce the emission in the roads. And vehicle kilometer travel, that is temperature, humidity, and altitude, and all will be the input for your model. And what are the output you will get? Vehicle emission inventories by the pollutant. So what each pollutant, how much it is emitting, that and all you can easily get. And then vehicle type contribution, because you are giving vehicle type as input, so you will get what are the type of vehicle emitting, what are the types of pollutant. Everything you can easily get from this emission models, and efficiency of the current policies, and the input data of the dispersion model. So how we'll evaluate the current policy, before the policy and after the policy, what is the emission reduction or what is the emission increase, that and all you can easily calculate based on the emission models. And vehicle emission trends and fuel combustion and their contributions you can easily get. Okay. Then vehicular emission inventory models. There are three models. One is average speed model, mobile, impact, and COPET. This and all no need to know. Just understand what are the models available and how it works. Based on that, you can also create your own model based on the factors what I have discussed, and whatever your city condition, meteorological conditions, everything will, because we have already discussed what are the meteorological conditions and the factors that influences your dispersion of your pollutants. So based on that, you can also design your own model. So just understand what are the models that are already developed by different countries, and how it can be applicable to in India, and what are the models available in India. That and all we can see here. Okay, so average speed models will be mobile, MSAC, and Copper. Instance speed models will be CMEM. That and all we are going to discuss in the upcoming slides. And multi-scale models are also available. MOVES and IVE. These are all. These two are most predominantly used models. Okay, so mobile is the model that is developed by US EPA. Except California, they are using this models to calculate the emissions from the highways. So mobile 6.2 is the latest version, and calculating emissions of mobile can be used to calculate the emissions of HC, NOx, and CO, because these three are vehicular emission transports, and motor vehicles, lightweight and heavy vehicles. So suppressed by the motor vehicle emission simulators, that is again MOVES. So first mobile will be suppressed by this model, that is the MOVES model. Okay, sorry, mobile model suppresses the MOVES model. Then MOVES model estimates the external geographical and climatic factors. These two also inputs to the mobile model. So it's based on external geography and climatic factors. One is ambient temperature, humidity, and altitude. Then calculate basic emission rate based for an average speed of 31.5 km per hour. This is the emission rate it is considering. Average emission rate. Okay, that is one. That's why it's called average speed model. And how to find this? By three factors, as I mentioned. One is speed correction factor, basic emission rate, and emission offset, that is the off cycle emission. So these three are the input you need to give. Then you will get the emission in per unit distance, that is EX. Emission in per unit distance you will get. The second model is MFAC model, that is the emission factor model developed by the California Air Resource Board, CARB. So the input of the model is provided by CALIMFAC, that is another body or the model, California Motor Vehicle Emission Factor model. So you can get the input data from that. So as I mentioned, the mobile model is used in US EPA except I mean United States except California, but this can be used in California. Okay, for that this model was developed. So what is the fact? Because the name itself emission factor. So what are the factors considered? Like the several correction factors like VKT, number of starts, number of vehicles are provided in the impact by the burden model. Here you can see, other than BER, SEF, the other correction factors are also incorporated. Then third one is Copert model. This was developed by European Environmental Agency, that is EEA. So you can also go through their website and see how the model works. Okay, so in 1989 itself, they have transformed this model, and latest update was released in 2021. That is the Copert version 5.5.1. So this computes the hot running emissions, evaporative emissions, and non-reserve emissions. All the three can be calculated by this, and you can see what are the pollutants, different pollutants that can be calculated from this model. And it includes 105 vehicle categories belonging to 5 vehicle classes. Okay, so the comprehensive model emissions is CMEM model, that is National Cooperative Highway Research Program, that is NCHRP. So that evaluates the emission model of CO, CO2. These are all, you can see major vehicular emissions are CO2, CO, NOx, as we discussed PM. This four are important emissions, that is exhaust emission. Other than that, some HC and VOC may also have come. So most of these models will evaluate this basic five transport emission model, emission pollutants. Okay. Then comprehensive model emission model. This again you can see the tailpipe emission formula, and then how it is calculating. FR is the fuel rate, and G emission by G fuel is the factor, and the CPF is the time dependent catalyst past fraction, that is based on the engine. So based on that you can find how much tail emission is happening. So this is the overall flow chart. It is how it's estimating. You are giving the fuel rate, you are giving the emission out engine out emissions. Then based on the catalyst past fraction, you are getting the emission out of the tailpipe. Okay, got it? Yeah. So the other one is the Virginia Tech Microscope Vehicle Fuel Consumption and Emission Model, that is VT Micro. That is a second by second vehicle characteristics it will calculate. So it utilizes the instantaneous speed and acceleration. So based on that, you can calculate the second by second vehicle characteristics. So based on the test of emission rate, the fuel consumption for 8 light duty passenger cars and trucks. So based on that, that is the base for this model. and this is utilizing that factor as a base. And that other one is the EMPA, that is based on the mathematical model. So it was developed by a handbook emission factors for road transport and former European Artemis, that is the assessment and reliability of transport emission models and inventory systems and particular project. These are all collaborative project. They developed this model, and it is advanced measurement and modeling techniques that solves the differential equation. So as I mentioned, this is a mathematical model. So it solves the differential equation to find out the emissions. So the limitation is it does not include any dynamic behavior, and its inclusion of catalyst model and lead to the improvement in the existing model. Only it's used for light duty vehicles, not for heavy duty vehicles. And the third one, the last one is the passenger car and heavy duty emission models. As I mentioned, this is only for light duty vehicle. Then they developed for heavy duty emission model, that is PFM. So it was developed in Austria, and these are the different versions of this model. And then the data inputs are passenger car, light duty vehicles, heavy duty vehicles, all the numbers you are giving, then buses, coaches, everything you can give us the input data. So you can see how the model works. So this is a scheme of the emission model, that is PHEM. So you can see here what are the input and what are the emission transit maps. So based on that, the height you can see, that is emission, and these are the various parameters, that is in the x-axis and y-axis. And the other one you can see here, this is also called the gear shift model. Then modem. Modem is modeling of emission consumption in the urban areas. That is other model produced during drive. That is dedicated road infrastructure for vehicle safety in Europe. That is a program of the European Commission. So the model is capable of estimating fuel consumption and emission of these four pollutants. And the limitation is it is not capable of estimating the cold start emissions and evaporative emission from the high duty vehicles and motorcycles. So again, these are all limitation of this model. Also, it will not assess the emission of particulate matter. So you can see here carbon monoxide, HC, NOx and CO2 is there, but not the particulate matter. So that's the limitation of MODEM model. And then MOVES, as I mentioned, motor vehicle emission simulator is the MOVES model. This was developed by again US EPA. Again, it's not useful for useful for California, other than all the US states are using this. And MOVES 3 is the latest version, came in 2014, and it estimates different types of emissions like engine running, starting, throttling, evaporative, brake and tire emissions. So all the exhaustive and non-exhaustive emissions are included in this model. So input is the inputs are the vehicle counts, vehicle miles traveled, temperature, fuel location, and country specific inputs. So that's why it's only useful for US. That's what the limitation of this model. You can see here, the other one is IVE model, International Vehicle Emission Model. So it was developed jointly by this are the organization you can see, and it was funded by US EPA again. So it takes into account various technologies and conditions that exist in the developing countries. So that can be used, as I mentioned, that is only for states. So this you can use for developing countries also. Yeah. So the inputs are tire and type and age of the vehicle, local conditions such as ambient temperature and pressure, because meteorological condition will help you in dispersion of this pollutant, and fuel specifications. So it's estimate the criteria pollutant, greenhouse gases and toxic pollutants, like all the pollutant you can see here, IVE model. So CO, volatile organic carbon, NOx, PM 2.5, everything you can see that can be estimated by this IVE model. So basic equation you can see, these are all the definitions. So you can see the basic equation here. There are two basic equations. The first one estimates the adjusted emission rate. The second one weights the adjusted emission rate. Final step is to multiply this results by the ratio of the average velocity of LA4 driving cycle. So you will results this overall fleet running emissions for allocated time and distance in gram. What are the pollutant you want, that you will get. Okay, so these are the two basic equations. So you can see the definitions of this notations in the above slide. Yeah. So the limitation is mobile moves cooperate are developed only in developed only in the developed countries like US, Japan, and Australia. So the difference in the technology infrastructure driving cycle will not be suitable for our country, like in India or any developing countries. We can't use the same model. So the emission factor also, if you see, enhances the error in the model emission outputs. The other one is IVE model was designed for developing countries. As I mentioned, IVE is developed for developing countries. However, the complexity of the model is similar to US and the European models, because it's too complex. You had seen the two equations and all, difficult to compile such complex data set. So it is not able to give output for more than a year. So that is another limitation. and then you can see most model require experimental data which are not available for Indian conditions. So if you have any model which is suitable for Indian condition without much data collection, then it is suitable. Like country with more population, it is difficult to get this data, and most models are region specific. So for that, in India, they have developed the model called WAPI model, that is Vehicular Air Pollution Inventory, WAPI model. So it designed specifically for developing countries like in India. So incorporated climate correction factors, because that's what missing in other models. So they have taken the climatic condition of the developed nations and their own region specific. But here you can also incorporate climate condition correction factors. So that shows fair agreement with the air quality observation in India. The model is simple to use and it is available in public domain. Yeah, so it's available for free. So the here you can see the growth in the vehicle per 1,000% over time is assumed, because based on the growth rate of the vehicle, you can calculate the emission. And the one car plus two-wheeler per family are assumed as a saturation level. That's all assumption I am talking about in the WAPI model. The seating capacity of the auto rickshaw and taxis are 3 and 5 respectively, and it can be saturated level 1,000 per person are assumed to be 330 and 200 respectively. So if you go to the WAPI model, you can also download the WAPI model. I can also show you in one of the upcoming lectures how to use this model. So here you can see you have to first give what is the city and what is the altitude of the city, and then vehicle category, and then the projection year. If you want to calculate for the past and if you want to calculate for the future, you can give the initial and the final year. And then the available data you can give from which year to which year. Based on that, it will calculate. Okay, so if you click OK, it will calculate. So the other input parameters, you can see the vehicle type, GDP, that is the vehicle is to estimate the future vehicle population, and the phasing out age of the vehicle, and population, vehicle ownership, saturation level. That and all we have seen already the assumptions, and then vehicle kilometer travel and temperature, humidity, and altitude are the correction factors. So here you can see the core architecture of the WAPI model. Running exhaust emission will be calculated based on the vehicle kilometer traveled and ownership. All this vehicle things are used to calculate the running exhaust, but the emission factor is used to calculate the adjusted emission factor. Also, the meteorological parameters like altitude, humidity, and temperature is used in the correction factor. Then adjusted emission factor will be incorporated. Finally, all these emissions will be calculated. Also, this PM10 and 2.5, that is a non-exhaust emission, that also can be calculated. These are exhaust emission, you can see. And running losses like volatile organic carbon. So three results you will get. So this pollutions, what are the pollutants considered in the WAPI model? In the running exhaust, CO, HC, NOx, carbon dioxide, PM, benzene, all these aldehyde groups and organics you can see. And then running loss evaporative emissions, as I mentioned here, running loss evaporative emission, that is the VOC, and non-exhaust emission like PM10 and 2.5 also you can get in the WAPI model. Then running exhaust emission you can see here. This is the equation for the running exhaust model. This is the equation, climatic correction factor equation. This is all available for free. I mean, these are the base for the WAPI model. These are no need to calculate, no need to muck up this equation. Just if you give the input, it will calculate and give you the emission values and altitude correction factor. Then vehicle population. If you know the vehicle population of this year, and if you give the final year, and it will give you the vehicle population rate, growth rate also you have to give. Running evaporative emissions like the volatiles and all, you will get by this equation. Non-exhaust emissions like PM and PM10, 2.5 heavy metals are also calculated in this model. Okay, so you can have a proper comparison or a summary by this table, the MODEM model, PHEM model, where what are the advantage, what are the disadvantage, who proposed this model, everything you will get this in this table. Okay, wherever it's applicable and all you can get. So on a conclusion note, for the transport emission inventory, I am saying, so the rising motorized and the fuel demand. So it's in the first slide itself we have seen, this is the fuel demand, and fuel combustion is a major contributor to the air pollution and greenhouse gases. As we know, CO2 is the emitted majorly from, I mean 90% from vehicular emissions only. So vehicular emission include tailpipe emission, non-exhaust emission, and evaporative emissions are the three major emissions of vehicular emissions. And then this model was developed by several countries, and the WAPI model is used in India, which includes the climate correction factors also. Okay, so we have discussed about the transport emission inventory. Now we are going to discuss about the emission inventory for the industrial sector. What are the models available? So here you can see the industrial, what are the pollutant will come from the industries. So industrial activities that uses the combustion of fossil fuels, again like the transport, but here you are using the fossil fuels to make it the energy demand responsible for emission of air pollutant and greenhouse gases. Again, it's a major contributor again. So industrial emission, you can see the combustion of fuel, you will get energy, you will manufacture, but emission will be there. So like what are the fuels they will combust, like coal, fuel, oil, biomass and diesel they are burning. Like agricultural waste also they are using as one of the fuel. So the factors affecting the industrial emission, what are the presence of large number or small scale industries, number of industries I am talking about, and then use of outdated technologies. So that will also emit what we say, like more emissions, like you know, like old auto and new auto, how it will emit, an old bike and new bike if you compare, that is again the outdated technology will emit a lot. And a lack of policies to control pollution, inefficient waste disposal. Waste disposal is one more factor that will contribute to the emission. Unplanned industrial growth. So if you have 10 mld water treatment plant for your existing industry. If you are building a new build, if you are expanding your industry and you are expecting you the water treatment plant to treat the excess water that is coming out of the new expanded building, then it is difficult for the treatment plant. So if you are planning for a extension, you you have to plan for proper waste management facilities, water and water treatment, wastewater treatment, and waste treatment and disposal facilities. You have to plan for even for growth extension of your industry. That's why nowadays all the pollution control boards are mandating to get consent from the pollution control board, anyway from the state pollution or the central pollution control board, to get a consent for new industry to be established, or consent for extension, that is consent for establish or consent for extension. So you have to get both the consent from the pollution control board. So they will come and scrutinize what are the things that is already available to take care of the new extensions. That and all they will take check before giving the consent. So that will also contribute to emission, right? So the status of industrial emissions in India, if you are talking about, so the stack emission play a major important role with a high content of high ash content. In India itself, we have 36 million micro, small, and medium enterprises. So our major economy is from this type of small scale industry only. So we can't close all the small scale industries, but emissions are more. How to control the emissions from this type of small scale industries? That's what we have to work on. And the financial and technical capabilities are more constrained for control of pollution in the small scale industries. That's what I have mentioned. So the first model available is Markle model, that is market allocation model. It was developed by the cooperative multinational project over a period of almost 2 decades. And it is a model compliance with the UN framework convention on the climate change. So after that convention, this model was framed, and then it interconnects the conversion and consumption of energy, the primary supplies, conversion processing, and the end user demand for the energy services. These are the three defined networks used to calculate the emissions. So you can see here the broad approach using the model, that is EK is your emission of any pollutant. You are using the activity rate, unabated emission factor, removal efficiency, and actual application of rate of control technologies. So that will be neglected. That is a control facility. Okay. So you can see here the framework for the model. So your population should be projected, your GDP should be projected. Then the sectoral, based on all the different sectors, it will choose the industry, and the Markle model will work out, and model output will give you the emission inventories. Okay. So this Markle model is used to calculate the emission inventories from different industrial sectors like cement, iron and steel, aluminum, glass, paper, fertilizer, brick, and power plants. So if you see these are all case studies, or the factory that you have used the Markle model, and the results are projected here. If you see the cement manufacture industry, the projected emission, so 2001 to 2051 they have projected based on the data from 1990 to 2000 or 1980 to 2000. What are the data you have, you can give, and you can run the model, and you will project the emission. So you can see here from cement manufacturing you can expect a large emission of sulfur dioxide. You can expect in 2051 you can see how much emission is there from the cement manufacturing, also the NOx. So the past and projected emission from the cement factory in India you can see here. And if you see the iron and steel industries, mostly sulfur dioxide and carbon monoxide are emitted from the iron and steel industry. This is again a second largest steel producer. India is the second largest steel producer in the world, with production standing from 110 million tons in 2019. So you can expect a large amount of pollution from this type of industry. So how to control this? That's what we are going to see in the upcoming weeks. And then aluminum production, you can see I mean, the growth rate is so low, so the emission is also very low because we are now shifting towards the plastic era. So the emission got reduced. But if you again move backward, then aluminum production will also increase, then the emission will also get increased. Okay. Then glass industry, if you see, this is again saturated, but still increases there. It's in 10 times increase. So emission is still there. Again, it's NOx and SOx only. Then paper industry, if you go, paper production is again 2.6 percentage of the world's paper production is in India, and the per capita waste paper consumption you can see 9.3 kg in India. One person is consuming 9.3 kg of paper, but China and US, if you compare, 42 kg and 312 kg of paper. So paper production industry is getting bloomed, and you can see the expect the carbon monoxide and sulfur dioxide from where the sulfur dioxide is coming from. This is coming from the burning of fuels, fossil fuels in the production industries. Okay, so like you can expect the wood burning or coal burning that will emit most of SOx. So that's why our chimney was designed. You know, right? Our chimney was designed based on how much height. I mean, chimney height is based on how much CO2 emission and how much SO2 emission. Sorry, not CO2. Particulate matter emission and SO2 emission from the coal nuclear power plants and all you had seen, right? Yeah. Then the fertilizer industry, if you see, a fertilizer will be required. You can see the India is an agricultural country, so we are using a lot of fertilizer. So again, NOx will be there, CO will be there, and you can see the particulate matter and SO2 is getting decreased because the invention or the modification in the technology of manufacturing fertilizer is getting changing day by day. So you can expect the less PM emission and SO2 emission from the fertilizer industries. And brick manufacturing and the kilns in there, you can see there is a large emission of again carbon monoxide. And power plant, again they are using a lot of coal and wood, and coal power plant will emit a lot of SOx, NOx and carbon monoxides. So gain is a model used to calculate the emissions from the industries like greenhouse gas and air pollution interaction synergies model. This is the GAINS model. So model growth in the range, that is a regional air pollution control information model that was developed originally by ISA APD. That program some 20 years they have developed this model. Okay, so if you see, GAINS estimates most of the parameters from the industries like SOx, NOx, VOC, PM, ammonia, greenhouse gases, methane, N2 and F gases. And then this you see on the data supplied by the countries themselves. So it can be used in any state and any country. So for each country they will estimate the any country or any particular region also you can estimate the emission. So they have a 2000 specific emission control measures and their cost. So this GAIN have two operators. One is scenario analysis mode, another one is optimization mode. Okay, scenario analysis mode is emission pathway from the source to impact, providing estimate of the regional cost and environmental benefit. But optimization model is emission can be reduced mostly cost effectively. So how to calculate the emission based on these two models, that is scenario analysis and the optimization mode. Another three ways are there. One is simulation of the cost effectiveness analysis, and cost benefit assessment. These three are the interventions with the interventions of this GAINS tools. See here, the input, I mean the output based on different pollutants. So the health impact, vegetation damage, and climate impact. If you have run through this life cycle assessment tools and environmental impact assessment tool, the impact will be like this: how much global warming potential, how much ocean depletion will happen, how much vegetation is spoiling or damaging, what is the climate impact based on different pollutant you can see here. So the color coding also you can see. Okay. And then GAIN model interface, if you see, this is the software tool. If you proceed to log in, this is the home page. Okay, GAINS online. If this is a home page, just click. You can see gains.ias.ac.at. That models. If you can see this home page, just click on proceed to login. Just click on your continent. If you are going with India, you can say with Asia, and then go to the this type of account details you can give and just go with the basic model. Activity data, emission control data, emissions, cost and all you can give us the input, and air quality impact, scenario management, data management, admin, these are all what you can say interfaces. First, you can select the emission. What is the emission you want? That is PM or CO2 or NOx, SOx, anything you can select, and then specify the pollutant here. Then click on the results. Here you can see the gain contains many scenarios. You have to select one of the scenario. You can see all the scenarios. This is one of the scenario Eclipse model, and select the region of interest. In India, I mean in Asia, you can select India, and the pollutant you can select, and then click on show. So you will get the all the scenarios you can see here. This is the result. If you select PM, this is the result of 1990 from 2050. It will give you a result based on the key sectors. Okay, so you can change the chart type. You can change the data labeling like bar chart or any graph type. You can change and you can export into any image type. And also you can get it in the Excel form. If you want to add scenario and if you want to compare two scenarios, first click on one scenario and also you can add other scenario and you can compare the two scenarios result in a bar chart graph. Okay, so this is one of the case study. They have used the gains model. Here you can see it's a emission inventory study on Kolkata metropolitan city, and they have base year as 2010 and 2015. They have calculated the PM 10 22.5 and BCOC calculation. And here you can see the sectors as industries only they have chosen as a major emission inventories, emission sources. So gain city model was used. Here you can see India cities, policy framework for Indian pollution and GHG mitigation. That's what they aim. So all the four operational coal-based thermal power plant within the study area of 2015 were considered. So medium, small, and micro scale. That is the orange category. Pollution wise, they will categorize the industries like red, orange, yellow, white. So green and white. So white is non-polluting, green is pure, and then red is more polluting, then orange is medium polluting category, so moderately polluting category. So based on that we can the pollution control board has categorized the industry, so you can see the industry categories in CPCB website. And scenarios, if you see, they have a lot of scenarios. One is business as usual, clean air scenario, LCA scenario, and act scenario. Here there is current and declared regulation legislation will be there. The second one you can see advanced control technologies will be there. The third one, cleaner and more energy efficient fuels are considered, and advanced control technology scenario, best available technologies and advanced pollutions controls. So if you taken any of the scenario, what is the emission reduction that can be calculated, shown in your results. So scenario you can assume. If the policy is good, what will be the reduction in the pollution? If the technology of production is good, what will be your emission reduction? If your air pollution treatment is good, emission treatment is good, then what is your I mean treatment control, air pollution control system is good, what is your emission reduction? So that and all you can compare by comparing different scenarios. Okay, so the conclusion is under the BAA scenario, BM10 and NOx emissions are projected to increase considerably. BAU scenario is what? Current and declared regulation. So if you are using the same regulation, your emission will surely increase. Okay, then ACT, LCA, and CAS were considered to the aim of better air quality, because ACT is what? They are advanced control technology. LCA is what? More efficient fuel usage. ACT is better available advanced air pollution control policies. So this, if you are using this type of scenarios, then your pollution will reduce obviously. So we can propose the government, you have to change your strategies and the regulation to reduce your pollution in this type of metropolitan city. That's what the aim of this model development. The final conclusion is industrial emission will contribute a lot of total emission. So insufficient combustion of fuel will contribute a high emission of particulate matter and NOx and you can say carbon monoxide. So Markle and Gaines are available to estimate the industrial emissions. So both are available for free. You can go through the website. Okay. So I will also show the website possibly in the 13th week if possible. I can take one more additional class if possible. Then emission inventory for the agricultural sector. So first we are discussed about the transportation and the industrial sector. Now we came to the agricultural sector, because agricultural burning causes a lot of pollution, air pollution. Also, you can the causes for Delhi's air pollution is due to the weather condition in Delhi. Also, the burning of crops in the nearby states, that also contributes to the emission of particulate matter and accumulates in the Delhi's region due to this climatic condition, meteorological condition. So this is one more cause is agricultural emission. So that also we have to model it. Okay. So not only the burning, also the enteric fermentation in the cow and all, you can see lots of methane will get emitted, because there is a rectum. A rectum will act as an anaerobic digester, and most of the food is digested in the cow have 4 rectums. So they will digest in the rectum and it will produce a lot of methane. So also you can see this type of termites are one of the most contributor for the methane, because termites have its own gut where the anaerobic bacteria will act and it will emit a lot of methane. So methane's it's a global warming potential is higher than CO2. It's about 24 times more. So methane is one of the air pollutant again. So N2O from manure management, and then ammonia emission from the agricultural activity. So whenever you are fluffing the uh, land for sowing seeds, you will see lots of ammonia emission. And open burning of agricultural residue, again it will release the particulate matters. So you can see what are the emissions here. So cow may emit CH4, and composting may also emit the CH4, and fire may emit all the carbon particles. And then soil respiration may release nitrogen, may be released like N2 and all. And then rice cultivation, paddy cultivation again releases carbon methane. So paddy cultivation is one of the major contribution of methane from the agricultural sector. So you can see ammonia is released from mineral fertilizers. Particulate matter is released from burning, crushing, and movement of livestock, and machineries also will emit particulate matter, because whatever movement in the field will emit particles, right? So that is one of the problem here. The nitrous oxide, if you see, nitrous oxide will be emitted from the soils, because the soils whatever that may also fix the nitrogen for the growth of the plants, because the bacteria in the roots of the plants and also in the soil that will fix the nitrogen in the atmosphere, that will also give nutrients to the plants. You can also think about the nitrosomonas and nitrobacter that will fix the nitrogen in the atmosphere to the plants roots. So you can also think about that emission. And volatile organic carbon also emitted from burning of agricultural residues. So these are all emissions from the agricultural sectors, the air pollutions. And methane may emit from the manual treatment, like whenever you are doing composting in anaerobic condition, methane will emit. If it is a aerobic condition of composting, then it will emit carbon dioxide. Then from the guts of cow also, methane will be emitted. The nitrous dioxide will be produced from microbial processes, and carbon dioxide will be produced from fuel combustion. Got it? Then, as I mentioned, if you are doing the emission inventory data, you will see most of the emission will be from the enteric fermentation, that is from the cow. And then agricultural sector is represented as 14% of the total greenhouse gas emission. So because methane is produced, so that's why it's contributing a lot. Okay, so if you see, this much is, total is 28 lakhs 38,000 gigagram of carbon dioxide equivalent. So if I say 1 gram of methane is emitted, then the global warming potential, I can say 24 gram of equivalent to CO2 equivalent, because 1 gram of methane, if it is produced, like, it will be equivalent to 24 gram of CO2 equivalent. So like that, if you see, the global warming potential will be always expressed in terms of CO2 equivalent. So out of this much gigagram, 14% is contributed from the agriculture sector alone. So here you can see the pie chart. Enteric fermentation is contributing more than 50%, and the estimation is taken for enteric fermentation, farm operation, and open burning. The results and all, you can see the the calculation equations. Emission of methane, we have to take number of animals and animal type, that is the J, that and all you can select from the models. And here you can see the N2O emission and carbon dioxide, carbon emission due to irrigation, carbon dioxide, carbon emission from the tilling and sowing, that will also emit lots of carbon dioxide. And pesticide production and transportation may release carbon dioxide carbon, and fertilizer may release the carbon dioxide carbon. So you can see this type of and open burning, it's again problem for particulate matter emission. So there is a separate model developed by the IPCC, that is the emission inventory. So here you can see the whole equation for open burning of agricultural sector. So that is EPOL, emission from the particulate pollutant. So what are the tools used to estimate the agricultural emission? That is the AG module. So agricultural emission estimation, then GLEAM-I model, then AgroChain greenhouse gas emission model. So you can see one by one. So AG model of the state inventory tool, that is developed by USEP again. So they have a different sectors here. You can see the modules. You can say so sit and projected tool calculated by the US state level estimates only. You can't use it for India. And 11 estimation models are there in modules are there in the AG model, and one module to synthesize estimates across all modules. So if you see different module worksheets and what are the gas you can get. So if you are thinking about rice cultivation, you can think about methane that will be emitted. So you can select models based on the based on your process and your expected results. So you can see default models you can select, and data input requirement and individual default data check boxes. Based on that, you will get the results. And then the Agri tool that is used to measure the agricultural emission inventory. So that was developed by European Commission. So it's developed for livestock, agriculture, soil, and field burnings. So you can see what are the type of pollutant you can estimate. Okay, so then the third one is the GLEAM model. GLEAM model is used to measure the emission inventory for agri and agriculture only. So that was developed by Animal Production and Health Division of FAO in Rome. So they have 6 livestock species and their edible products. So what are the species? What are their edible products? And that and all you can give us input, and the model can cover the emission of methane, carbon dioxide, nitrous oxide, and using IPCC methodology. So here you can see the first one is your emission intensity, protein production, and total emission. The second pie chart will give you the breakdown of emissions from which sector, I mean which animal, that and all you can easily get. And the third, final one bar chart, this two bar chart you can that shows the breakdown of emission by sources and sources of feed. So what are the feed you are giving? Based on that, what are the emissions will come? So based on this calculation, you can reduce the methane emission by changing the feed to the fetched to your livestock. Okay. Then final model is the AgroChain. It's not a model, it's a tool. So AgroChain greenhouse gas emission tool. So that was developed by again CGIER and CCAFS. So that estimates the total greenhouse gas emission associated with the food products. So the crop greenhouse gas intensity and the food loss factors along with the chain are also considered. So here you can see how the model looks like, what are the input, and so here you can see the scenario comparison, what is the geographical location, and complete set of laws and emission factors you can see here, and what are the entries for the crops, and finally the result you can see here. Got it. So this they have used it as a case study in one of the area in India itself. They have done this case study. So for the burning sources in the agriculture. So biomass burning is the second largest global source for the trace elements. So they checked the emission factor applied was evaluated against the crop residue used for the domestic combustion in the Delhi. So they categorized the 4 main crops, main categories and their crops. So you can see the crop emission was calculated by this equation. So they used the residue to crop ratio, dry matter factors that and all contribute to the CH4 emission. So they mapped the emission for volatile organic carbon. So volatile organic carbon kilograms per kilometer square was mapped here based on the state wise or region wise, you can see. So significantly you can see the northern part of the India was the emission due to the crop residue burning was more significant in the northern part of the India. You can see here and here, and northeast part. And it is you can see the burning of sugarcane residue is more in the terms of southern part of India, like Karnataka, Andhra Pradesh, and Tamil Nadu. So that and all they have estimated based on the crop type and volatile organic carbon emissions. Then the uncertainty analysis also they have done to estimate the timing as well as the spatial distribution of the emission. So the generalization of the emission factors leads to the uncertainty. So uncertainty was their largest generalization, largest uncertainty was largest for the generalized emission factors. So from the case study, what they have concluded is the magnitude and spatial distribution of the volatile organic emissions from different solid fuel combustion sources across India was mapped, and a large seasonality and occur predominantly during the Kharif and the Rabi season. So they have assessed season wise to check the uncertainty, and they have found that Kharif season and Rabi season produce a lot of emissions. During that time, the crop burning seasons, that time and all, we can expect lots of emissions, and that reduce and also it reduces the significant NMOC emissions. For preventing the emissions, you can also suggest the policies to the government. Finally, for the agriculture sector, contributes a lot of greenhouse gas emission because enteric fermentation itself accounts for more than 50% methane emission. And methane from the livestock enteric fermentation and nitrous oxide from the manures are the major contributors. And the open burning again contributes a large amount of PM emission. That is particulate matter emission. So this three carbon methane from enteric fermentation and nitrous oxide from manure management and particulate matter from the open burning. These three are the major source of pollutant from the agricultural sector that can be assessed with these five tools. Okay. And the fourth one is emission inventory for the residential and commercial area. I'll speed up here because this is a mostly equation part and no need to worry about the equation. This will not come for your exams. Okay. So, residential, you can't think only the industry and transportation will emit air pollutants. Also, in our homes, you can expect the air pollution. That is called indoor air pollutants or the aerosols. So, how we will expect the air pollution inside the home? Because we are using fossil fuels. Earlier, we have used the fossil fuels as a source for cooking, and nowadays we have moved to LPG. And still, most of the rural parts are still having this I mean, what do we say? Wood as a source for cooking. So household including domestic cooking and use of fireplaces, they are considered as residential sectors for the pollution. And the household stove, although small or numerous, they have the potential to contribute. Even you can expect a small quantity of emission from each household, but the number of households and the population of India, if you consider, it will be a huge emission. Okay, so that also taken into account for policies. So that is residential sector. What about the commercial sector? Like cooking, heating, boiler operation, captive tube power generation. These are all commercial areas that in the offices, restaurants, shopping malls, and the hospital. That also crematorium may emit a lot of pollutions. Even though it is a smaller in quantity, but the numbers are large. So you can expect this type of pollutant from the residential and the commercial areas, all the air pollutant you can see here. And according to a policy from the Collaborative Clean Air Policy Center, this is statistics you can see, like transportation, power plant, industries. Finally, the HAP, that is hazardous air pollutant. I mean, household air pollutant is more. Household air pollution is higher compared to transportation, industries, and power plant. You can't think only the transportation is causing more. The industries are causing more emission. Power plants are emitting more. Our households are also emitting a lot of air pollutants. So that need to be taken into account. That is for PM 2.5 I'm talking about, because it's a fine powder of wood and all will create PM 2.5. Okay. So here you can see again energy industries are generating a lot of emissions from the commercial sectors. Other sectors are contributing 10.3, and the manufacturing industries and the transport you can see here. Yeah. So the basic equation for estimating the residential emission is this one only. So J is the type of fuel, and consumption of fuel rate. You can, if you give as an input, you can get the emission of pollutant I from the fuel type J. So that you will get. Okay. So it's the procedure is you have to calculate the fuel consumption rate. You have to calculate the total emission. Finally, you can also vary the temporal and spatial distribution. The basic equations for commercial emission is they are also considering the subsector K along with the pollutant I and the fuel type J. They are also considering the subtype K. So what is the subsector? That is you can see here which type of industry or which type of commercial unit. Based on that also, based on that they are calculating the emission from the commercial sectors. So first step is to calculate the fuel consumption rate per subsector. That is very important. Then the total emissions for the commercial sector. Finally, the temporal and spatial distribution. So again, they have used this in a case study conducted by Terry in New Delhi, the development of spatial dissolved air pollution emission inventory of India. So here you can see The pollutants, these are the pollutants considered for the residential sector. First, you have to define what is the sector you are going to consider. So they have taken residential sector, and they consider both the urban and the rural areas as a comparison study. And 75% of the people are engaged in the agricultural activities. Areas is within the revenue limit of the village are considered as rural, and all other areas are considered as urban. Okay, so the pollution from the emission from the particulate matter pollution was calculated by this equation, and this was the equation developed by Terry again. Population was projected for different years based on the annual population growth rate, and the household number was projected. So if your population is increasing, your household will also get increased, right? So household population in 2016 was projected from 2011, that and all they have calculated. And how many households are using kerosene, how many households are using LPG as a fuel, that also they have adjusted, and the adjusted number of households are calculated. So here the same formula was used for LPG again. So the adjusted number of households are calculated from for using the LPG was calculated again here. So you can get an idea what are the factors need to be considered for calculating the emission inventory. So if you want to calculate the emission inventory for your smaller region, for your household or your college or institution, you can also consider various factors. So these are all not mandatory. You can adopt any equation, any growth rate, and that should have a proper literature background that you can take as a base and you can use the equation. Okay, so just I am going through, give you a glance of this. Yeah. So here you can see the fuel wood is contributing the results I am just giving you. So they have considered all the fuel types like kerosene, LPG, kerosene for cooking, kerosene for lighting, coal, cow dung, cakes, and crop residue, fuel wood. These are all our fuel for cooking. So what are the pollutant will be emitted from this? So if you see as a bar chart level, PM10 and PM2.5 will be emitted more from the fuel wood compared to LPG and kerosene. There is no PM emission. But if you consider SOx and NOx, again that will be more in the fuel wood and from the coal. And carbon monoxide will be more from fuel wood and this one. That's why we are banning now fuel woods. And if you see non-volatile organic carbon will be more in LPGs. So the case study concluded that higher estimation of PM10 into SO2 was attributed to the attributed. So increase of LPG uses simulates the decrease in the biomass uses. So that that also decreases in the kerosene consumption in lighting and cooking, because nowadays no people are, I mean, most of the people are not relying on the kerosene for lighting and cooking in India. So the present study says that the growth of electrification in India decreases the PM 2.5 and SO2, because lighting we are using through electricity. So that decreases the PM 2.5 and SO2 emission. So that is obvious. Again, that's what the study also concluded. Then also they have estimate another case study estimated the wastewater treatment plant emission in the megacity of Delhi, and they have compared two scenarios again. You can see I will go to the result anyway. So CH4 from the this formula will be useful if you want. So the emission from municipal solid waste can also be calculated from, so this is the methane emission. How much municipal solid waste is generated? Because I am from a solid waste management background, I have used this formula many time in the, you can see if you are dumping your municipal solid waste in the landfill in anaerobic digestion, how much methane will be emitted, how much landfill gas will be emitted, that can be used to get the energy out of it. We will calculate using this formula only. So this is again a USEPA formula. So municipal solid waste, how much you are putting in the landfills, and what is the methane correction factor, what is the degradable organic matter present, because only the organics will degrade and give you the methane. So and then again correction factor for the DOC, and finally a fraction of CH4 in the landfill gas. So this and all used to calculate the emission of methane. And R is your recovery. If you are recovering this much, that also need to be subtracted. And then oxidation factor is also considered. So another one is the methane from the wastewater. For that you need to know the how much liter of wastewater and what is the BOD level, that is milligram per liter. BOD, you know, that is the organic matter present in your wastewater. So if you are a civil engineering background or environmental engineer, you know what is BOD, biochemical oxygen demand. So that will give you the indirect value of how much organics is present in your wastewater. So based on that, the correction factor and all if you give, you will get the methane emission. So the result, if you see for NOx, volatile organic compound, and CO, the carbon monoxide is getting decreased. if you see from 1990 to 2000, because carbon monoxide from the domestic fuel uses a strong decrease, causes a change of traditional fuel to the cooking gas. That's why you can expect the less amount of CO. And in NOx, if you see, the area shows increase because NOx is getting increased because of fuel wood to the cooking gas if we moved on. So CH4 was mainly 80% emitted from the solid waste disposal in the landfills and the dump sites, and the CH4 emission have increased over the last decades. That's why nowadays government is focusing on reducing the greenhouse gas emission from the dump sites and landfills. And this trends reflects the population growth in the Delhi, calculated as a constant waste per person. And if you see the residential and commercial sector may consist of several point sources that will limit the air pollutants, and major emitters are incomplete combustion. Yeah, and rural population are more exposed to the domestic emission. That is another important point to note down, because they are all still relying on fuel wood for cooking. So that should be changed to reduce the emission of particulate matter. Finally, we are going with the application of remote sensing in air quality management. As of now, we have seen how to get the emission inventory in the transportation sector, agricultural sector, industrial sector, and domestic and commercial sector. Now we are using remote sensing to get the data. How to get the data by remote sensing? You know the basics of remote sensing is the art and science of collecting information about the Earth's surface and phenomena using sensors, not in a physical contact, because it's laying somewhere and it's giving the data to us as a remote. So that's why it's called remote sensing, and not in a physical contact with the surface and the phenomena of the interest. Here you can see this is a basic principle. If you have a source of illumination and the radiation will go and it will touch the target and it will be recorded in a sensor that will be given to the transmitter receptor, and the data was analyzed and interpreted and it will be used in the application. That's why remote sensing. So that was applied in the air pollution management also. So you can see here the satellites are used to map the biomass burning, industrial burnings, and the sandstorms in the Earth's surface. So satellite remote sensing of the troposphere is a rapidly growing field, and it measures the trace gases and the aerosol. Nowadays, people are not relying on the equipments to measure the air pollutant. They are now relying on the satellite data to know the how much carbon dioxide in the atmosphere level, how level in the atmosphere. So sandstorm, forest fire, biomass burning. So everything, all the meteorological data and this type of data, air pollutant data, are based on remote sensing only nowadays. So the need is like in India, there is a bridge, there is a gap due to vast geography and wide spatial resolution, because people are only working with the US or only working with the UK. That models are not applicable to India. So if you are using satellite data, that can be used to predict anywhere in the world. So that gap was addressed by this remote sensing application. Then long range transport, and which is difficult to achieve with the traditional ground monitoring. So that can be achieved with the remote sensing. Why it's required in India? Because air quality monitoring network density, if you see, only in India we have 0.14. That is a very less density. Number of monitors per person, if you see, our population is higher. So if you are having this much population, we need to have lots of air quality monitoring networks. For that, if we have satellite data, then that will increase your density of air quality monitoring. If you see the most of the developed countries and developing countries having the similar population near to us, they are having a large density of air quality monitoring network. So how to get the satellite based data products? That is by aerosol optical density, that is the AOD, and gaseous columnar volume densities. So these two are used to get the air pollution data. So the trends in the pollutant concentration and to develop the emission inventories for major source of the air pollution, we are using AOD and gaseous columnar volume densities. So here you can see the domains and different time period, the data products, and the satellites what's giving us the data. So if you want the UV aerosol index, you can get from the NASA and ESA data. If you want the aerosol layer height, you can also get from this type of sources, satellite sources. And the application is it will give you the air quality forecast. For future also you can forecast easily, and improved characterization of the surface level air pollution, and improvement of emission inventories, monitoring of the air pollution data, validation of the model. You can calculate through the equation what we have discussed in the last 4 lectures. But to validate that, you need the real-time data. To get the real-time data, you can rely on the satellite data. Okay. So the identification of air shade, demonstration of the episodic pollution, and inspection of the consistently non-compliant sources. So these are all the applications of remote sensing in air quality management. So you can see here there is a sensor here, there is a receptor here, so it's allowing the UV light whenever a vehicle passes, so I'm talking about the transport sector. Whenever a vehicle passes, passes, there is a emission that can be monitored here. So emission rate for the whole fleet, if sufficient data are available, you can easily get. Okay, so that's based on the light. You can see the principle here. A light is paused whenever there is no movement of the vehicle, so the light will be easily get into that receptor. But whenever the movement of vehicle is there, it will create a pollution, so the scattering of light will UV light will happen, so it will not reach the receptor fast. So based on the background data and your current data, you can get the how much particulate matter or VOC is getting emitted. That's what the principle. So there is a speed bar, there is a UV source, there is an infrared spectrophotometer that will assess the scattering. Okay, and remote sensing instrument, if you see, these are all the first unit you can see, that is a vehicular emission, measures the vehicular emission. The second unit measures the speed of the vehicle, and the third unit measures your records the data of your vehicle, like the number plate and the type of vehicle and all. Again, you can see this type of hanging remote sensing devices are there that will give you, that is a emission detection and reporting system, EDAR, and developed by Hager Environmental and Atmospheric Technology, that is heat. So the laser light, it's a source that is from the top. If like a lamp post, it will show, scatter the light, and you can get the reflectory strip that will measure the scattering of light. Here you can see the mounted light source, and the later light is scattered back to the reflector strip, and the later beam sweeps the whole breadth of the road. So the how much emission spatial wise also you can easily calculate, and the exhaust plume is captured in its entry. Okay. So based on the absorbance band in the spectrum, we have three types of sensors. One is NDAR. NDAR, as I already mentioned, it's used to, non-dispersive infrared is used to calculate the measure the carbon. So CO2, CO, and hydrocarbons can also be measured. UV light is used to measure NOx and SOx and ammonia. Okay. So these are the sensors you can use. But the limitation is, during ideal condition, you can't capture the because if there is no movement of vehicle in the road, so the light will always pass and it will record zero pollutant. But there may be a background concentration. If you feed, then only it will give you the result. So there may be emission, but that will not be captured by the remote sensors. And then measurement is more difficult when raining and wet surface is there. So that is another disadvantage. Cloud cover is one of the other disadvantage. Identification of location and count of this fires, that may also if you are searching for agricultural fire, then other fires like forest fire may also happen. That will also the error may be there in this type of remote sensing applications. So there is a tool called CREAMS. It's an interdisciplinary research initiative. So they developed a model to calculate the agricultural burning through remote sensing. Again, the limitation is, as I mentioned, it's not only restricted for crop residue burning. It will also measure what are the types of burning in that. And then industrial emission can also be calculated by remote sensing. From the thermal power plant, they are using a Trompe model. So that model is used independently tracking TPP emission in India. So you can see again the limitation is the cloud cover and aerosol properties. Though if there is a lot of interference with the cloud cover, you can't measure the data. So here you can see the Trompe data for Delhi. Due to high spatial resolution and high signal to noise ratio, easy to distinguish the individual NO2 plumes. So you can see where are the NO2 plumes are coming out. So the red marks will give you the high plume concentration. Again, the wind data and the presence of cloud will affect the data collection. So the PM emission remote sensing can also be applied. The model is MODIS, MODIS, that is a moderate resolution imaging spectroradiometer, and numerous aerosol measurement including aerosol optical depth product reflecting fine particulate loadings. Here you can see the aerosol optical depth. The optical depth expresses the quantity of light removed from the beam. So the beam is there. How much light is removed from the beam by scattering or absorption of the aerosol particle or particulate matter. So if you see here, if there is no particulate matter, the light will pass directly to the receptor. But if it is any aerosol particle, that will reflect. That is called the Brownian movement of that we have studied in our schooling. So light extinction are used to represent the aerosols. Again, AOD, as I am mentioning, aerosol optical depth, that the column integrated value So AOD is a function of shape, size, type, and number of concentration of the aerosol. That all we will get. Okay. So again, PM also can be calculated based on the aerodynamic diameter. As I mentioned, 2.5 is based on the aerodynamic diameter. We have discussed in the earlier days what is the aerodynamic diameter of the particle. That also can be fed into the formula, and you can calculate the concentration of the particulate matter. So here you can see the representation. That's a visual imagery of the remote sensing data. So the cloud image you can say. So the low values in blue, high values in the red mark or orange mark, and the vertical bar gives you the PM 2.5 quality of based on the EPA category. Okay. So if you are moving forward, there are some action plans given by the government of India to manage the air quality. So there is a MOFCC guidelines, CPCB and the SPCP guidelines, and there is the air quality forecast system. The satellite data given by the IITM Pune. So that and all will give you the proper system. So on a conclusion note, I'm saying like satellite remote sensing provides a complete data and synaptic view, but there are still some limitations to the air pollution application in the remote sensing application in the air quality management. Okay, you can also refer this references, and I will also show you this models. I mean the gains model and moves model in the in my portal, if possible, in the 13th week. Okay, thank you so much, and we will move on to the problem solving session. If you have any doubt, please post it in the chat box, or you can also unmute and you can ask the questions. Or else I will move on to the problems, the old assignment problems. Hope you have done the 5th week assignment. I don't think there is no extension of the dates, but hope you have given the 5th week assignment. Yeah. So if you have any doubt, please unmute and you can ask. Okay, then I will move on to the problem solving session. Please post the answers in the chat box. I'll move or read the question and the options. Please post the answers in the chat box. Okay. So the first question is, what is the primary cause of exhaust emission? Uh, Modis. Yeah, I will explain again. So they're asking about Modis. Yeah, this one. Moderate resolution imaging spectroradiometer. I hope you are asking about this. Yeah. So this is one of the remote sensing application to predict the particulate matter emission. So we have discussed about the emission inventories for transportation, but agricultural sectors, urban and I mean domestic and commercial areas, and this industrial sectors. But the remote sensing can be applied to all these factors, emissions inventories, but also for PM emissions. So one of the model is moderate resolution imaging spectrophoradiometer, that is MODIS instrument. So that was developed by Earth observing. Sorry, that was the instrument on board with the Earth observing system. So including the aerosol optical depth product reflecting fine particulate loading. So that is a detector. You can the detector techniques that is used to calculate the particulate emission. So as I mentioned, how to use this. How to get the particulate matter reading is based on the scattering principle. So if you have any aerosol or a particulate matter, the light will be reflected and it will be scattered by the particulate matter. And then the remaining light which is reaching to the receptor is measured, and the scattering is directly proportional to the amount of aerosol particle present in your path of the atmosphere. That's what the aerosol optical depth is. The optical depth expresses the quantity of light removed from the beam by scattering or absorption by the aerosol particle. So if the aerosol optical depth is higher, then your particulate matter is also higher, or the aerosol particles is higher. Hope you got the basics of the model.
Hello, sir. Good evening.
Yeah.
This is Debabrat Sethi from Odisha.
Yeah, sir. Please.
Sir, actually, I had one small doubt.
Yeah, please.
This is based on the light scattering principle, like
Yeah.
NEA.
Yeah.
And is it not taking the moisture into consideration while calculating?
That's what the limitation I have mentioned. It can't be used while rainy days and the cloud cover is there.
Okay.
Yeah, that's what the disadvantage with the remote sensing application in the air pollution. So
And
we have also in our project to calculate the methane emission from the landfill, as I am working on solid waste. I have calculated the methane emission from the landfills. So we have relied on the NASA's satellite images and data to calculate the methane in our Trichy dump site to calculate the methanes. So we have checked the methane seasonal variation. So we checked from January 2020 to December 2024. So in these regions, all the months are not giving the value because we have given cloud cover as 5%. If the cloud cover is less than 5% only, you have to give the data. If the cloud cover is more than 5%, we are rejecting the data. So we got out of 3 into 12, 36 months, we got data for only 10 months because we are giving less cloud cover. But the data are available for
Okay.
every month. But the accuracy of the data, you can check with that.
Okay. Okay. Thank you. Thank you, sir.
Yeah. Yes. Now, can I move to the problem solving? Okay, that's enough. Okay, I will read the question. You can also post the answer in the chat box. So, what is the primary cause of exhaust emission from vehicles? As I mentioned, there are three types of emissions from transports or vehicles. One is exhaust emission. The second one is the evaporative emission. The third one is non-exhaust emission. So the non-exhaust emission is from brake wear, that brakes and the tires, and the emission. Evaporation emission is from fuel evaporation. The exhaust emission is from the combustion of fuels. So incomplete combustion of fuels in the engine chamber will cause you the exhaust emissions. So the options are brake wear, road resuspension is non-exhaust emission. Evaporation of gasoline is evaporative emission. Brake wear is non-exhaust emission. So only the exhaust emission is incomplete combustion in the engine chamber. So the answer is C. I hope you got it. Yeah. So we had discussed here the exhaust emission is the emitted from the tailpipe as a result of incomplete combustion of fuel inside the engine chamber. So you can expect this pollutants because fuel, whatever the diesel, petrol or carbon source. So carbon dioxide will be there, carbon monoxide will be there if it is incomplete combustion. If you give more oxygen, carbon dioxide will come. So again it's containing nitrogen. So nitrous oxide will come. So whenever you are burning something, particulate matter will also emit. It's a carbon source, again hydrocarbons will come. Volatile organic carbon will come directly if it evaporates. So that's what these are all called exhaust emissions from the transportation sector. Okay. Yeah. So second question is
Sir, your voice is not audible.
which of the following air pollutant is not considered in the WAPI? WAPI model is used to predict the emission from the vehicles, correct? Because lots of the models are developed from the United States of Environmental Protection Agency (US EPA), or most of the models are developed for developed countries. That's not suitable for India and its Indian climatic condition. That's why WAPI is developed to address the climatic factor into the model. So they have given all the pollutant, considered all the pollutants, emission pollutants from the vehicles, but one of this is not. Because industries, there won't be any heavy metal emission. I mean, this is the assumption. Most of the fuels, I mean, for the industries I'm talking about, fuels like coal or whatever the firewoods they are using, that will not emit heavy metals. That's why heavy metal is not considered in Gaines model. Okay. Yes. Then the fifth question. If you know the answer, please post it in the chat box, or you can also unmute and you can say the answer if possible. What modes of operation are available for the Gaines model? So they are asking what So, scenario analysis uses different scenarios to compare, like environmental benefits, which is good, which is not good, and which regional cost is good, or which climatic factor is good, or
Your voice is
which,
not clear, sir. Hello.
still,
Your voice is not clear, sir.
okay, 1 second. Can you check now? Is it
Yes,
fine?
sir. Yes, sir. Yes.
Thank you so much. Sorry.
Yes, sir. Fine, sir.
Okay, so the Gaines model uses operated in both mode. Natural activity interact in the atmosphere, producing secondary inorganic aerosols. So to produce secondary inorganic aerosols, again, ayyo, I don't know why my voice is not clear. I will reconnect. 1 second, sorry. I'm sorry. Is my voice fine now? I'm sorry. Am I audible now? Is it proper?
Yes, sir. Yes, sir.
Thank you so much, sir. Sorry for the disturbance. Yeah. So here they're asking how the methane emission producing secondary inorganic aerosols. So methane will be because aerosols are like inorganic aerosols are ammonia is organic. So inorganic aerosols are NOx and SOx. How it will be?
Yes, sir. Your screen is not visible.
Okay. I'm sharing now. I just left and came back. Yeah. Share. Yes. It's fine now. Okay. So, ammonia will react with the SOx and NOx. It will produce a secondary inorganic aerosols. So that's the answer. Here you can see the explanation like ammonia emission from the agricultural activity react with the atmospheric SOx and NOx and produces secondary inorganic aerosols like N2O and all will be produced. Then the eighth question is, which of the following is considered as a fuel combustion activity in the commercial sector? Commercial sector, because residential and commercial sector emissions we have learnt now. So domestic cooking, boiler operation, fireplace use, rural heating.
Boiler operation.
Yeah, boiler operation will be from the commercial sector. Yeah. So the other activities like cooking, heating, boiler operation and captive power generation in the commercial sector, such as hotels, offices and all are considered as a commercial emissions. So that can be calculated by various models we have proposed. Yeah. And the ninth question is aerosol optical depth. So that's what we have discussed in the Modi's model also. So expresses the quantity of light removed from a beam by dash by aerosols during its path through the atmosphere. It's a process of dispersion, diffusion, scattering and absorption. So aerosols are measured based on the scattering principle of light. That's called aerosol optical depth. It expresses the quantity of light removed from a beam by scattering or absorption. It's given adsorption. Adsorption is not a principle. Both are different. Absorption is by surface. Adsorption is onto the surface. I mean into the surface. Okay. So that's a scattering principle. Then final question is, what does aerosol optical depth correlate in satellite based air quality monitoring? So we have discussed various applications of satellites, I mean remote sensing in air pollution inventory data analysis. So AOD is used to measure the atmospheric pressure, atmospheric temperature, particulate concentration, wind velocity. Yeah, particulate concentration. So AOD is used to predict the particulate matter emission. That's what the application of remote sensing in predicting the particulate matter emission. Yeah. Thank you so much for joining the fifth session. So tomorrow we are having the sixth week section. So please join for tomorrow session also. Please don't forget to give your assignments on time, because if you want a certificate, you have to give assignments as well as the final exam. Hope you have registered for the exam. Thank you so much for joining. If you have any doubt, you can ask. I will be in the meet for next 5 minutes, or else you can leave. Thank you so much.
Thank you, sir.
Thank you, sir.
Thank you so much. Yeah. I hope you have registered for the exam. I think the last date is over already. The deadline for exam registration is over. Yeah. Hope you have no more doubts. I leave the meet. Thank you so much. I will end the meeting. We'll meet tomorrow.